Hello, everyone. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. Today, we've got the latest additive manufacturing and 3D printing news for you, and we're going to present that to you in a concise as possible way, and hopefully include a little analysis that'll be helpful. We have 7 news items for you today, and the first one is a WASP building made by the Institute for Advanced Architecture of Catalonia. WASP is an Italian company. They make 3D printers for clay and other materials, including very, very large ones using gantry systems, also large kind of cylindrical type systems. And the company really, WASP is a bit different than other OEMs. They're much more focused on kind of the benefit to society element. And they're much more radical, if you will, than a lot of other companies are. And they really have a mission to transform architecture. We have a lot of companies that are 3D printing concrete or cement kind of things, often with established materials companies. And WASP wants to do something completely different. And that has a lot of impact. As noted in, I think the article originally came from Design Boom, as noted in that article, about 36% of emissions worldwide come from building materials, and building could even comprise more depending on what you would include in that kind of emissions number. So this kind of a building is an earth building that was built in Catalonia with alloy, egg whites, and enzymes. Most of the materials were within 50 meters of where the building was built, and only some of them had to be imported. This is a zero waste building, which means that the idea is that everything will built from dust, if you will, and will return to dust. And it is built with as little energy use as possible. Hopefully, as well, there's near zero emissions on the building in the long run. So this is an interesting architectural experiment, right? It also, one other thing before I forget, is that it's got a bunch of cavities in the walls. It functions like kind of an air gap to circulate air one behind and also insulate the building. And I love that as an idea of having an insulation kind of process in that keeps your building cool when you need to be cool and keeps it from losing warmth when you need it to be when it's cold outside. So I love that idea of this implementation. Now, you might look at this and think, it doesn't look like my house. I'm not going to move you're not going to move your 6 kids and your golf bag into this place, right? I understand. But if we really want to radically look at emissions and really want to see how we can really change, then using completely new materials is going to be the way forward. And again, this may not work in suburbia, or it might take a long time to percolate through to, I don't know, New York or something like this, or it might be unfeasible for that location. But imagine just that the WASP building process here is only going to be used by certain people who want cabins in nature, or certain people who want houses in nature are very environmentally conscious, or farmhouses, or something like that. That already would be a huge impact, not only for the 3D printing industry, but on WASP bottom line as well, and also just for the planet. So I think we should pay a little bit more attention than you might at first glance think to things like this. It looks like a kind of fanciful kind of architecture kind of experiment, but it could have real implications. The next thing is the Anycubic Photon Next. Now, this isn't a 3D printer, as all 3DP stated when they did the article. It's more a concept printer. So what the Photon Next is that's essentially a new way of pitching a 3D printer, and I like it because of this. I like it because what Anycubic is saying, this is kind of our new printer, and this is kind of like you have a concept printer, just like other people have a concept car, and we're working on it. But they don't have a deadline for it. They're not saying we're launching the system now and then coming out with it many years later, as some other people have done. No, this is like they're saying, this is a concept, I'm going to put it here. Just like car companies use concept cars to get discussion, to get love around their brand going, to get people to, get feedback and ideas and excitement going. And they're doing a similar thing. The printer now is supposedly, the concept printer supposedly works at 1600 millimeters per hour, which would be incredibly quick. And it has got zonal illumination, which I guess would be some kind of new masking technology or some kind of other way, and a 10-inch 8K mono LCD. So I like that this tells us where Anycubic thinks the market is going. What I also like about this thing is that Anycubic is experimenting with a kind of design language here. We can talk about this design, we like it or not like it, but it is something new. It is a new way of presenting this. It's a new way of looking at printers. If you look at all the desktop market, automakers are very recognizable, also because they kind of have the color white, essentially. But nothing else really, everything else is a clone, or it's very much using the same design cues and design language. So even if you're like a really hardcore kind of desktop printer operator person, I challenge you to recognize printers without the labels on them. It's very, very difficult. Not only because they're clones, but also because they're kind of all, yeah, kind of same, and in the way they're designed. So I like the way that Anycubic is doing this as a discussion thing, and I like the way that they're kind of saying, "Hey, we're going to come up with a new way, a radical way of presenting our printers in the future." And I think this very much, especially that distinctive design, is something very, very. It would be a very good idea for them, I think, to do this. And I like this as a methodology. I think more people should do this. But what I would suggest doing is just saying, "Hey, you know what? We have two printers. We've got the ultra fast, super small printer to print small things really quickly." Right? Or we've got a bigger build volume, more expensive system, the form factors maybe not going to fit on your desk. What do you go for? What are your customers excited about? That kind of thing to me would be really helpful, because now everybody kind of designs printers in isolation. We don't tend to use things like focus groups or other stuff. Not that that's especially a good idea, but to get a lot of input on people and to find out what people really find is exciting about the future, I think could be a very exciting thing. The next news is about Fleet Space extending its 3D printing capacity. Fleet Space is an Australian 3D printing company, or actually a satellite company, that wants to make 3D printed satellites. What's more, they want to make 4 to 8 of them a week and end up making a constellation of 288 satellites. What they're also doing is commercializing their constellation. For example, they have an exosphere, which is kind of a tool for mining to find deposits and stuff like this. So it's I think a very interesting business model, very interesting go-to-market to kind of commercialize these kind of fleet production processes, and the owning a fleet of satellites in a kind of like tooling way to get companies to use it. Also, this means they're essentially going to have to serially produce 288 and perhaps even more satellites on an ongoing basis. Up until now, Fleet Space was making certain components, the RF components, in-house through 3D printing, and they've now increased their capacity. So RF components are very, very important for 3D printing. Optisys and Swiss 212 are doing this already publicly. Other people are not. They're doing it much less publicly. These RF components are the way the satellite communicates with the ground station. And these can be optimized through 3D printing. Not only the geometry is optimized through these kind of RF components, but also what we can do is integrate these components so that in a clean room environment where we're assembling the satellite, we just have to click in one component instead of like assembling a whole bunch of components in this very expensive per hour type of environment. We can optimize the weight and the reduced mass, of course, which is very important for satellites because it affects your launch costs. But also any kind of mass reduction also means we can put more functional stuff on the satellite. Not by reducing the necessary. So the company in Fleet Space is already printing its S-band RF patches, right, which communicate in low Earth orbit with the ground. And now it's expanding to printing most of the things. I would think that if you're going to be making a fully 3D printed satellite, it's a very good idea to do this much earlier. And you would need to print your components. If you find out a way that you don't have to print all of your components, that in and of itself, and you can outsource that in and of itself would be quite revolutionary. And would be a key advantage as well. But in this case, Fleet Space now wants to do a lot more printing in-house. They've hired 80 people, another 30 extra in the last couple of months, in part because they want to do a lot of this production. Now, what they've done right now is they've chosen to get from Konica Minolta, actually, to buy a DMP system from 3D Systems. Good win for 3D Systems, because right now in space and space applications, many of the companies have been choosing for Velo3D, EOS, AMCM, and it's good. It's a good win for them in this industry. And the company hopes to get more speed and flexibility, which of course is going to happen once they learn how to deal with this machine and make components. So I think it's a very, very good move by the company. And think about the production capacity on 288 fully printed satellites, right? Think about how big of a client this could become for 3D Systems, just compared to all these other clients. Up until now, you've got the car companies, you've got aerospace, but we need to realize that these comparatively small and unknown up until now 3D printing startups for space could be using could become some of the biggest clients for 3D printing. And everybody's been focusing, of course, on SpaceX and the more famous companies. But even like a relatively completely unknown 3D printing space company could be using a lot of 3D printers. So this is fast becoming the new space or commercial space industry is fast becoming one of the most important, if not the most important, area of this market. I mean, if we look at these 12 lasers, really large systems, these kind of things, these are really, and also the focus on large components, this is really being driven more by space industry than anything else. Because the other guys like orthopedics and automotive care about, more about cost or more about accuracy and other things more so than trying to print these large components. So it's, the sign that this is going to be a very, very big thing for us. Number 4, the Coast Guard turns to 3D printing. So the U.S. Coast Guard is doing a 3D printing kind of pilot. Now, this in and of itself is nothing new and nothing really exciting, but I love the way they're doing this. What they're doing, they have a pilot 3D printing shop, which from March to September 30th let people submit ideas to it. This is being done by the Surface Forces Logistics Center Industrial Operations Division. And what their goal was, is to reduce maintenance costs and reduce repair and maintenance costs, and to supplement the existing supply chain through other means. Now, what they did is, rather than doing a competence center or force people to use it or something like that, they just had an open competition. Submit your ideas, show your fellow Coast Guard people what you're capable of doing. And they're actively looking for Coast Guard personnel that has 3D printers at home. So they're saying, hey, we have so many people and so many technically minded people. There are going to be 3D printer owners and operators among our staff, and we want them to come up with these ideas. And empowering that group, we know that this has led to great advantages in a number of companies where this bottom-up 3D printing growth has happened because Dieter took apart what he made at home and showed it to his boss, and then they ended up implementing jigs and fixtures as a classic example. But the Coast Guard is actively doing this in a contest, and then also encouraging these 3D printing owners to come to them with their ideas. They're also starting with desktop printers and polymer, right? The easy stuff. So I love this as an implementation. This is classic, and it's really, really well done. I love it. What they're coming up with is shipboard electrical covers, training aids, pieces for MH-60 helicopters, which I think maybe they should print and rely on a little bit later in the process, and replacement of a plastic handle that's part of the cutter of the ship, fire equipment. And this is the component. You can see it here. Normally it's a rubberized component, and it opens like a kind of valve for firefighting equipment. What often happens is this thing breaks down and degrades and is unusable. And now they're trying to 3D print it. What also happens is, if the thing is unusable, they have to replace a $476 component. And now they can take a $3 to $4 3D printed item and replace it. Now, we could discuss the design here, and we could probably also see that there could be some problems with this design and it may not work. And I would like to use like a GF or other material here to do this. And it may be a better use case for binder jet, for example, than another technology. And definitely they would need to use a stronger material. But I love the idea of doing this, and I love this coming up from the ground up, asking people to look around their ships and then try and find what they can use and what needs to be improved. Another example, something we don't have a picture of, it's called a Chalkfest dam. I've never heard of it either, don't worry. It's a thing that helps them on the 87-foot patrol boats replace the engines. So when they put in a new engine, apparently, they take some time to align this engine, and they need like components to align it to get it actually level and when they put in the new engine into the boat. So what they've done is they've 3D printed a component that makes this easier. It saves them a day, which is an awful lot if you're thinking about the operational readiness of the ship and taking it, you're getting it into service a day earlier, potentially. It avoids a $1,300 cost per engine, and the process reliability is increased significantly as well. So I think these are fantastic examples. And I think this is, to me, as a gold standard implementation of 3D printing. I love how they're doing this. And then the contest, getting everyone to use their 3D printing skills they already have, empowering people to use this. And what is the most important thing, I think, is that everyone is going to see this on the Navy Times or whatever internal publications they have, Coast Guard Times or something. and they're going to know what works and what doesn't, and what is a feasible component for AM. And they're going to be able to implement these components themselves, or come up with ideas that are in line with things that are actually achievable. What is it? The problem in 3D printing in organizations, or implementing in organizations, often is that people come to you with stupid ideas, but they don't know that, or they come to you with unrealistic ideas, or they come to you with like completely random ideas that take you very long to figure out that they're not feasible. By promoting the feasible and promoting the individual crew member who did this, they can engender lots of people to come up with lots of solutions that actually work. So I love this. I think this is a textbook 3D printing implementation, according to me. So I think it's absolutely fantastic. The next news is that Materialise has bought Identify 3D. Identify 3D is kind of end-to-end security platform, or a security tool for files. If you're being mean, you can call it DRM for 3D printing, but it's meant to ensure the security of a file as it is transmitted or shared, and it's meant to ensure the integrity of that process and integrity of the file. What I think is almost more important is that it bundles the file with the settings information, which could include operator settings information, so that somebody can replicate it. Think about, you know how to make this thing in Leuven, but you have a service bureau in New Zealand that has to also do it for you. So this blended environment where you're producing some things yourself and you're outsourcing some things requires you to really define very well what is a part and what it takes to make it. And we all know that in 3D printing we have a lot of process steps and stuff, and we all have to ensure that the correct file is sent with the correct total recipe. Yes, in PLM we have stored a lot of that information, or a lot of it is in CAD, but we have to, when passing the file in the order to somebody, we have to make sure that is bundled and that process kind of happens correctly, especially if we're talking about lots and lots of parts and scenarios where you print this part, somebody else prints that part in your company at a different location, and somebody else is an outsourced partner. Then you really have to figure out how to do this, and how to do this in a good way, because it's going to become very difficult. And you also want to control what information comes out of your system or not. So this is a move that I think was kind of like, of the Materialise acquisitions, this is broadly expected, I think, for them to acquire this or something similar. It helps secure their CO-AM platform, which is kind of a cloud strategy for Materialise, and also kind of an app store for other people to join to sell their solutions to Materialise customers. And it's quite clear what Materialise's intentions are. Like, on the one hand, they could buy more and more companies, not necessarily very gigantic companies, to add newer modules that they can upsell to their customers. And at the same time, they can add core functionality to the CO-AM platform where they're lacking it, to accelerate the adoption of this CO-AM platform, which would then make it more attractive to its existing customers and new customers. So it's a solid strategy going forward. I think they could do this for a very long time and come up with something very, very profitable for them. The next thing, this really, I think, threw us all for a loop. If you know, if you've heard of this already, then I think it's really good. If you haven't heard of this, I need to explain it correctly to you, because it's completely insane. If you haven't heard of this, it's completely insane. This is Desktop Metal, and Desktop Metal is deciding to go into digital sheet forming, right? And this blew me away. I did not expect this at all, completely, in a million years. So what is digital sheet forming, and how come I've never heard of it? I had never heard of it. Maybe it's a thing already. I don't know. Sheet forming itself is a kind of super commoditized thing where you print a tool, or, well, usually they're not printed, they're just CNC'd. You CNC a tool, and then you ram a sheet down on it, and it forms into, or you can print a mold. There's a couple of different ways to do it, but generally what you're doing is you're banging out in one sheet, you're banging out a hood of a car, or you're banging out a door or something like that. A ton of stuff is made out of sheet metal, which is really inexpensive, banged into shape, if you will, by one tool. And this is like being, it's a $300 billion industry. It's huge, right? And it's the polar opposite of 3D printing. It's commoditized sheet. It's smooth. It's easy to make really large surfaces. It's kind of the opposite of 3D printing. So this is completely unexpected. I think it's quite brilliant, this. Although it puts Desktop Metal completely outside of the additive business into something completely new. The tool itself, we can see it here, it's a ceramic tool, and essentially it rams down on a sheet, and it's digitally creating this. So instead of having to make a tool to press the sheet down on, or used to press the sheet, depending on what you're doing, this beats it out. So if you've ever seen these Jamaican guys make these steel drums, this is kind of what they're doing. The Jamaican guy making a steel drum gets like a tool and he gets a hammer and he bangs out an oil drum essentially, and makes all of the surfaces go the right way by beating them out one by one to make the oil drum into a musical instrument, the steel drum that they use as a typical kind of Jamaican music. Um, they've essentially made this into a machine. I don't know if somebody went to Jamaica and kind of then copied this into a machine. To me, it seems like the logical way to get inspired by this. But the idea is that rather than making this tool, which costs you time and money, you can just digitally put in the file, and this tool will, or this kind of head will beat it out of the shape, and you could make a completely different hood next. The next thing, right? I love this for making like other things like thermoforming parts and other parts as well. If this works, which I don't know if it does, but if it works, it could be a very exciting development. Think about being able to do lots of different sheet formings or custom sheet form parts, custom shapes, being able to make lots of sheet forming for like room dividers or things like that, or new kind of wall panels, but then include some design elements or something like this. So if it works, it's really interesting. Rick Phillips said of this that the tool, by the way, which is like is push button. You get the sheet metal part formed, and that is with amazing complexity, like the hood of a car, very rapidly. And they're saying that they can get a fully formed part in less than an hour, which is kind of a longer time than it would normally take. But again, it's less inventory, less tooling, it's more direct, it's quicker. The forming area is 1450 by 1000 millimeters. They can go up to 400 millimeters deep, and they can use steel of up to 2 millimeter thick plates. So I don't know what the market size is for this, that they can actually, the actual addressable market size with this tool for this thing. I don't know if the lead time, this hour-long part thing, is going to be a huge constraint because the cycle times are usually much, much shorter. Or I don't know who the ideal customer is for this, but it could be. I could really imagine that there's a lot of use cases that you can come up with. So this is a hood element that's been formed. I think additionally, yeah, I don't know. This is a really surprising move, I think, by them, and it really points to them wanting to disrupt more markets than just additive, and wanting to really build excitement in the future for themselves around this future disruptive technologies in many more areas. So the number one news item for the day is Optomec showcases automated print cell. So Optomec is a company I really love what they're doing, and they don't really get a lot of press a lot of times. And what they're doing is, well, Optomec is a company that makes lens printers, the DAD technology, and they also make aerosol jet, which is a 3D printing electronics and other materials technology. They do a lot of work for defense and industry. And one of the biggest things they've been working on for a very long time, for I don't know how many years, is turbine blade or turbine blisk repair. And that's where you use DAD, or in Optomec's case, their Optomec lens technology, which is usually you can mount it on a robot arm, or you put it in your CNC gantry if you want, or make like some kind of 7 axis, whatever combo, 5. And what you do is you essentially, on a worn down blade, you put in new material and then you cut it off using like CNC or another process. That there's a ton of turbine blades in everything, in engines, but also in tank engines, but also all sorts of applications you never thought of that would have a turbine blade. And these are very expensive, and they have to be repaired, or well, it's much cheaper to repair them than to scrap them. So DED is already being used by this for a very long time. It's already, and what now Optomec is doing is, together with a company called Acme Manufacturing, is they've developed a cell to do this. This consists of Optomec CS250 5-axis system, and the Optomec's AutoCAD software, and then tooling from the other company, Acme, they have an MRO blade tip repair system, which kind of actually can grind and then and polish these tips. The system also includes like automated feedstock handling, and also bedding things off and onto pellets. And I love this. This is the future. This is what we're going to have, like a specific factory setup to make a specific component in a very, very highly specialized and highly dependable way. That to me is completely and totally the future. So that's the news for today. And I hope you really enjoyed it today. I hope this was useful for you. And